Hey guys, so this is your midterm review topic 3. This is cell transport. So for cell transport, the goal of this is to reach equilibrium. What does this mean? All right, equilibrium, this first part kind of sounds like equal, and that's exactly what you're doing. So I want you to imagine a cell. All right, little pretty cell. Basically what this means, the point of cell transport, is to make sure that there is the same amount of whatever particle is out here as there is inside, right? So I want to make sure that there's the same amount of water outside as there is inside. And what needs to happen is some type of transport of whatever molecule we're talking about to pass the cell membrane. So this is my cell membrane. Remember, my cell membrane controls what enters and exits the cell. It's like a bouncer. It's like, hey, you can come in, hey, you can leave, things like that. All right. So with cell transport, there are two types of cell transport. There is passive transport and there is active transport. So passive transport, I'm going to do passive first. Passive requires absolutely no energy. Think like passive, you're just like watching people pass by from your couch, not really doing anything, not expending any sort of energy. Passive transport goes down the concentration gradient. What that means is that they go from I'm going to draw a little picture of a concentration gradient. Think of it like a slide. They go from a high to a low concentration. So they go from high to low. It doesn't really require any energy to go down a slide. I think of it like that. There are three types of passive transport. The first is diffusion. This is when any molecule moves from a high to a low concentration. Facilitated diffusion is when any molecule moves from a high to a low concentration with the help of a protein. And the last one. The last one is osmosis. This is specific to water. This is when water specifically is moving from a high to a low concentration. So that was passive transport. Active transport requires energy. Think like active. When you're active, you need to use energy. This goes against the concentration gradient. So if we picture our slide again, and we have high and we have low, this means that this is going up. So going from low to high, if you've ever tried to climb up a slide, you're going to need some energy to actually climb up it. Some examples. All right, the first is a protein pump. So if you ever see the word pump, that means that you need to use energy to move molecules, MLC is molecule, from a low to a high concentration. The second one is endocytosis. That means that large molecules are entering the cell. You need a lot of energy to like bring in those big molecules. And then the last one is exocytosis, which is when large molecules exit. All right, So that's your brief overview of passive versus active. I want to talk a little bit more about osmosis. So this is for osmosis, sometimes we call it tonicity. All right, remember that there are 3 types of solutions. There is hypertonic, hypotonic, and isotonic. Hypertonic is when you have more water leaving. So that means that there is a higher concentration inside and a lower concentration outside. If water is leaving, then the cell is going to shrink. Hypotonic is when you have water entering. So that means that there's a higher concentration outside and a lower concentration inside. Remember, because water always moves high to low. Remember, osmosis is specific to water, and its water is always moving high to low. If there is water entering, that means that my cell is going to get bigger, or it's going to swell. Isotonic literally means the same. I have the same amount of water going in as I do out. There's no high-low anywhere because it's the same. So nothing happens to my cell. So that is your review of cell transport. You can get started on the practice once you show me your notes and I sign it.